This is a solve session for Triomino puzzles from 2025. You can play along for free at notepadgames.com or download it from the App Store as Notepad Games. So we're just going to get started with the first puzzle from 2025. Up here on the top, we see we're trying to group all of these different color groupings into groups of 3 cells that equal to a value of 21. So let's just jump in there. 7 and 8 plus 6 would give us 21, and 8 and a 12 would need a 1 with it, so those two are going to be different. 6 and 9 gives us 15, needs another 6, so that is not what we're looking for. We have 8 and 9 gives us 17, we need a 4 to get to 21. Again, that does not seem to be what we're looking for, so I'm going to actually gobble up this 6 and make this 21. And then come here again and look, 8, 8, and 5 makes 21. Now we're coming to 7, 12, and 2 makes 21. And we have 4 vertical lines for the first puzzle of 2025. These were last year's puzzles. Let's jump on to number 2. Now we have a target of 9, same group size. All the Triomino puzzles are going to be a group size of 3. So just start looking through, seeing how we can group these into groupings of 9s. That was the second puzzle completed, nice and quick one. Just kind of making our way through. 6 and 6 makes 12, plus a 4 would give us 16. 3, 7, and 6 gives us 16. 5, 5, and 6 gives us 16, and a 4, 5, and 7 gives us 16. Moving along to the next puzzle, we have a different shape here, a lot more colors, target of 17. I zoom in a little bit, see if it makes it a little easier to see. Let us jump into some math. So 8 and 3 gives us 11. And we need another 6, would bring us to 17. 9 and 3 gives us 12, with a 5 gives us 17. 11 and 1 gives us 12, with a 5 gives us 17. 10 and 4 plus 2 does not. So that is a bad sign. 6 and 12 and 5 gives us 17 there. And then we have no possible way of getting to 17 from those remaining numbers. So something needs to be adjusted. So let us look back then at this purple. How can this 11 get to where we need it to be? An 11 and a 1 makes 12, and it needs a 5. But it could take this 5 instead, which would then mean this blue section would need a 5 if that's how we're doing it. But it could also be something like that. And then this yellow does not work as is, and this orange is not going to work as is. The orange needs to be a little bigger, so perhaps instead of this 4, instead of the 6, it could take this 8, which would make 17. This red could take a different 6, so that is still 17. But how does this yellow, 8 and 3, and instead of the 9, it takes the 6, so that's 17, 17, 17. Now we're looking at this blue again. We can go, I think maybe that's what we had before. So the purple and the green are not correct right now. Let me just erase this so I can see. The purple and the green. So if we're doing it like this, these have to take different numbers. That's for sure. So 11 and 1 is 12, and it would need a 5. So that's not possible. So I guess it could take that 5, but let's do the 10 and the 1 for now. This would need a 6, and the only 6 it could take is that 6, and this purple would have to take these 2. So it leaves us with a bit of a problem right there. I think this is kind of back to where we started. not seeing an easy way to make some small adjustments to resolve this, because if we take that, right, the yellow now is unhappy. So this may be, there may be something simple to adjust here, but there also may not be. This 6, if we're looking at this burnt orange color, that's 6 and this 4. I'm going to just clear the grid because sometimes you can get trapped. And think about this and this have to be 2 different colors. That's where I'm going to start there. This 8 and this 8 have to be 2 different colors because there's no 1 near them, so you can't take 8, 8. This 6 and this 9, but there's no guarantee that they are not part of that. This 9 has to be a different color from this 8 and this 8. And then looking up here, we have 8, 6 would be 14 plus 6. So this 6 can't be with this 8, and it can't be with this yellow. So I think these colors all have to be separate. So now how do each of them grow to grab 17? So I'm going to look at this purple first. We could do an 8 and a 5, gives us 13. Plus a 4 would give us 17. We could also do an 8, a 3, and a 6. So the purple can go either way. Looking down at this red, we could have 9 and 3 gives us 12, but that can't pick up another one to be 17. It could do this 9 and 6, but it can't pick up 2. So I think this red has to go that way. So that leaves 3 cells here. Again, we know the purple can go that way or that way. Sorry, the purple would have to go directly up or that way. Let us look maybe at this orange one. So we can have 6, 6, and 5, or 6, 4, and 7. We can't have 6, 4, and 7. There's no 7. So this 6 takes either this 6 or that 6. And if it takes this 6, it takes this 5 or that 5. But if it takes this 5, this 4 gets cut off from the world. So this 5 is not taken by this color. So this 5 has to be either the green or the purple. And if it's the green, we can still have 17 up there. And the purple would then come out like that, which is a possibility. And if the purple goes up instead, does the green just take these 2? So those take the same 6 cells, either one or the other. So I think either way, one of those is correct. So now again, if I think about like this, we cut off this 6. So this would take something like that. So now if we look at this yellow and this blue, I feel like we were here before. And this did not lead us to a solution. So that is a little worrying. 11 plus 1 plus 5 would give us 17, but that doesn't seem to be what we were saying. $14. Huh. Let me work through it. That could get to 16. 4 and 6. So clearly something was incorrect with my thought process, because maybe it was this assumption over here. Let me step back. Because this blue, that can't get to 17. The only way I'm seeing it get to 17 is right there. So perhaps I made a poor assumption somewhere along the way, where this is actually 17, 17, 17. Okay, where this feels better. This feels definitely like we were on the right track, and there you go. That was the solution. Definitely a more complex puzzle. Took almost 8 minutes. Let's see if we can finish one more puzzle off. Maybe it'll be a bit simpler. Target of 20, group size of 3. So we can follow a similar pattern. We know that some of these can't share the same color. The 9 and 11 would make 20, but you would need to take one more cell still. So that's not happening. This 7 can't join with this 11. It can't join with this 10. So this 7 is going to be a different color. And then this 8, the 8 could join with this 10. So I'm not sure yet where our last color is going to be, but that's okay. Let's just look at some of these. So this yellow, it needs another 10, which could be a 4 and a 6, a 7 and a 3. It can't be a 9, 1. So this 9 is not part of the yellow. There's no 3 that it would be able to take if it takes this 7. And there's no 6 if it takes this 4. So this is going that way. So the 10 could take 8 and 2 or 8 and 2. Can't take this 6. So I think either way the 10's taking this 2. And then either 8 or 8. This 7 needs 13 more. 9 and 4. 6 and 5 is 11. 3, it won't be able to touch an 8. So I think that is a requirement. Unless I'm missing something, that looks correct to me. The 11 needs 9 more. Could be a 6 and a 3 or a 6 and a 3 this way. I said that the 10 has to take that 2, so this can't take this 8. So I think regardless if it's 6 and 3 or 6 and 3, this 11's taking this 3. So if I look at the 9 now, the 9 needs 11 more. It could be 5 and 6, or it could be 5 and 6. I think in either of those scenarios, I made this mistake with the last one, but I believe that these 6 cells are being occupied by those. This can take 8 for 20, and then we have 8, 5, and 7 making 20. And that was the, I believe, 5th triomino of the 2025